Okay, and then for register bank selection, I think we also saw this before, right? So the PSW bits 4 and 3 allow you to select the register bank. And so if they're set to 0001, 10, or 11, then you select bank 0, 1, 2, or 3. And that means when you refer to register R0, R1, R2, or R all the way to R7, you actually could be referring to bank 0 or bank 1 or bank 2 or bank 3, depending on the setting in PSW. When you power it on first, it's initially 00, right? And so if you select bank 1, then R0 refers to address 8 on chip. Right? If you select bank 2, R0 refers to hex 10 or 16 decimal and so forth, right? So those are just different ways of getting to the same location. And registered banks are used later. I mean, we'll see how they're used in, for example, interrupt handling, or in some cases, quick function calls. Right. So to set or clear, right? Those are the ways to select the banks. Set B means assign it to 1. Clear means to assign it to 0. Right. So that's pretty straightforward. And then so then if you use register mode or addressing mode, that's more compact because you've seen the way these instructions are encoded. Register takes 3 bits, and a lot of times they get just encoded as part of the opcode byte. Whereas if you use direct mode, yes, you can always get to the exact location on chip, but that costs you an extra byte just to encode the address. Okay, so if you say R0, chances are it's actually taking up 1 less byte than if you say just 0 for the direct address, something like that. Okay, so and yeah, so your instruction tends to have higher density if you use register addressing. And in some cases, right, so there, what you may or may not have a choice, right? So, like I was saying, if you use ink R1, for example, that's 1 byte. Ink 01, that's 2 bytes. Even though if you're selecting bank 0, they are referring to exactly the same location. Now, some combinations like push does not take a register as an operand. So push R0 or R2 or R something is not allowed. You have to say it's direct address. Okay, so we have to say push 02 or something like that. Okay, so yeah, sometimes you do have a choice, other times no choice, and you just have to uh, choose whichever addressing mode is allowed by the instruction. And how do you know? Well, you take a look at the instruction set manual, and you can certainly go to uh, the, the data sheet or the KL website, Kaya website that I linked. Okay, so just a quick review of the memory address spaces of the 8051. There's on-chip memory and off-chip memories. On-chip memory is, well, there's the uh, actual the 0 to 7F, and that is what most people call iData. Um, and that's really for data and registers, bit addressable memory. Really, that's for storage. And then address 80 to FF, that part is for special function registers, but in direct mode only, right? Remember direct mode we just talked about, right? Like your push 02 or your move 02 or something. You give the address, and so by specifying the chip on chip address of this memory region, then you refer to either data part or special function register part. But there's an extension done for 8052. And in fact, when people talk about 8051 nowadays, they actually refer to the 8052 extension, which is there are actually two parts, two separate spaces, even though they have the address 80 through FF. Okay, so 8052 actually has extra 128 bytes of on-chip memory that use the same addresses as the special function registers, namely 80 through FF, but they are totally separate in the sense that if you use direct addressing, then you get to the special function registers. If you use indirect addressing, then you get to more data space. Okay. Now, so what's indirect addressing? Well, that's the addressing mode with a little at character in front of the register R0 or R1. In other words, you're using a register as a pointer, and you're reading or writing through this pointer. Okay, then you will get to the data part, and that's good for storing things, in particular for a stack, actually. But if you're using direct addressing, that is, if the address is hard-coded as part of your instruction, rather than going through a pointer register, then that's direct addressing, and you will get to the special function register. Okay, so that's a very common implementation, and that's really what's called the 8052 extension. And in fact, virtually all what so-called 8051 architectures nowadays are actually 8052 with this kind of extension. Okay. Now you might ask, okay, so if I go to the original 8051 and I try to use indirect addressing through the in the space of 80 to FF, what do you get? Well, that behavior I don't think is defined, and I don't think you'll get to a special function register. You just hit some space that's not defined. Okay, so but now no, the important thing here is this also means that you can access the special function registers only by direct address or by direct addressing. If you try to use a pointer, a register as a pointer to special function register, that will not work. It will not let you walk through these locations, these special function registers using a pointer. Okay, now so that's for the on-chip or internal memory or iData memory. There's two memory spaces that are external to the CPU core, but a lot of times they're on-chip. So there's data memory and code memory. Remember, 8051 is designed to be a Harvard architecture. Remember Harvard architecture? Separate spaces for code and data. So each one is 64K, namely 16-bit address, right? So you can go from 0 to FFFF, right? That's 64K locations. And to access data space, you use the move X instruction. To access the code space, you use move C. C stands for code. Okay. And so that means if you have some address, like 3000 hex or something, I don't really know which one you're talking about unless you tell me if it's in code space or if it's in external data space or something, right? So that means a pointer, if you declare a pointer in some programming language, you may have to say, what space does it point to? Okay, does it point to data, external data memory? Does it point to code memory? Does it point to what? Okay, and that's actually important. So this is unlike, say, for example, C programming language. You can have a pointer voice start, and it can point to code, it can point to a function, point to data, point to anything. Right? In traditional C programming language assumes one element architecture or integrated data and code, but 8051 they are separate. And so in next week or so, we start to see C programming language used for embedded systems. And there are ways to specify just which space or what they call storage class you're referring to. So it's no longer as straightforward as you're used to. You have to actually be more specific. And there are standard ways of annotating your C code declaration to specify what kind of space you're referring to. Okay, and these are things you don't find in regular C language, but they're part of NC standard.